Okay, so today we're doing some practice problems where we're putting all the information together. So if you had a free response question, how do you answer? What information is needed? And there are 5 steps to it. So again, this is for any sampling distribution problem where you're asked about a probability. So the first is you're going to define the parameter. And because parameters for population, we have to use P for proportion or mu for the center, the mean. Not p hat, not x bar. Those are for your sampling distributions. We need to check the conditions, and there's going to be 3 conditions. Describe the distribution of the statistics of the p hat or the x bar. And 3 things there: shape, mean, and standard deviation. Use our normal model to find the appropriate probability, and then we're going to interpret it in context. So this is where we get to write. So here's our example. This one is going to be a distribution with proportions. So the bad apple problem. And one of the first things I like to do is when I'm reading through the problem, start to identify things. So a large shipment of apples are inspected. The inspectors will select a random sample of 150, so that's N, from the truck. If more than 5%, so this is from the sample, if more than 5%, so that's P hat, in the sample are bad, then the entire shipment is rejected. Suppose that in fact 9% of the apples are bad. So the true proportion of bad apples is P. So that's not P hat. I goofed there, it's P. And what is the probability that the shipment is accepted? So we're looking for what is the probability that P hat is greater than 5%. So step 1, identify the parameter. P is the true proportion of all apples on the truck that are bad, and that's equal to 0.09. We need to check our conditions. The conditions that we need to check, is it a simple random sample? Yes, it was stated in the problem. It said it was, we took a random sample of 150 apples. So we do want to state that. You could put in quotation marks what it was stated in the problem, like I could, in quotation marks, say random sample of 150 apples. But somehow you want to show random sample and then what you checked. You don't just say yes. The 10% condition, this is to allow us to assume independence here. So the way we meet the independence condition is if our sample size is less than 1/10 of all the population. So it's reasonable to assume that 150 apples are less than 1/10 of all apples on the truck. The last thing is the normal approximation. We can assume it's normal if we meet the large counts. For proportions, we need to use the large counts condition. So that means n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. So 150 times 0.09 is 13.5. Yes, that meets it. And 150 times 0.91 is 136.5. That's greater than 10. So I've met all 3 conditions. Now I want to describe my distribution of p hat. Well, the shape is approximately normal. And again, it's because we checked this condition, that it met the large counts condition. The center, so mu of p hat, is equal to the proportion of the population, which is 0.09. The spread, so what I'm looking for is the standard deviation of p hat, my sampling distribution. And the formula for that is p times 1 minus p divided by n, all of that square rooted. There are the numbers, and I get a standard deviation of 0.02337. The more decimal places, the better. 4 is the minimum I would keep. Next up, we want to now do our normal probability calculation, and I've been asked to find what is the probability that if I take this sample on this truck, that it is less than or equal to 5%. So again, remember, we were asked, what is the probability that the shipment is accepted? That means that p hat must be found to be less than 5%. So that's what I'm trying to find. We know that it's normal. The mean is 0.09. The standard deviation is 0.02337. Draw your normal curve, write in the mean value, and then draw in the value you're looking for. And we do want to label that the x-axis represents p hat. So what I'm looking for is a p hat value of 0.05. What is that probability of having that or less? So I want the value to the left. Z is equal to, I can use one of these two things. I can either say it's equal to the observed minus the mean divided by standard deviation, or I can use the actual symbols, p hat minus p divided by the square root of p times 1 minus p divided by n square rooted. Put in my number, so I need either the one with the symbols or the words. I need the numbers, then I need the actual value. So here I got negative 1.71. Going to the table now, and again, I put a little note here. I got this value from the table. I got 0.0435. So that's step 4. The final step is the interpretation. And there's different ways to write this, but we need to get all this information in there. So given that 9% of all the apples on the truck are bad, the probability of getting a random sample of 150 apples with 5% or less being bad is about 0.0435. About is that word we use to hedge so that we can get away with not having to be perfect. Okay, let's take a look now. I want you to do one on your own, and that is the lefty desk problem. So the one thing, I wanted to cover that up a little bit. What we are looking for is that we know that 13% of students in a large college are left-handed. Our auditorium has 15 lefty seats. So in a class of 90, what's the probability there will not be enough seats for the left-handed students? Well, there's 15 desks, so we want to know what's the probability of 15 over 90, getting something greater than that. And I want you to work this problem on your own. Let me do one more practice problem for you now. I'm going to do one with means instead of proportions.